This is section 1.1, rectangular coordinates. We will only spend one day on this section. Now we're starting the new semester with something that's going to seem quite easy at first. Chapter 1 is a review of things you should have already learned, but even though these are things that you've learned before, it always helps to see them again because repetition is the mother of learning. All right, so what I ask is just be patient during these first couple of sections, which might seem too easy, because afterwards it'll get a little more challenging. The Cartesian plane. I put the Cartesian plane here. Obviously, everyone knows what Cartesian coordinates are. You know, it's where you have the x-axis, the y-axis, so that's obvious. But what a lot of students tend to forget is what the quadrant numbers are. All right, so make sure you get that straight. Quadrant 1 is right here, what I'm circling now with the mouse arrow. Quadrant 2 is what I'm circling now. Quadrant 3 and quadrant 4. So the order of the quadrants goes counterclockwise from the part of the coordinates, the part of the Cartesian plane that has positive x coordinates and positive y coordinates. Okay, so that's quadrant 1 when both x and y coordinates are positive. In quadrant 2, the x coordinates are negative and the y coordinates are positive. In quadrant 3, the x coordinates and the y coordinates are both negative. And in quadrant 4, the x coordinates are positive while the y coordinates are negative. The point in the middle, of course, we call the origin. All right, let's look at the distance formula. Again, you've seen this many times, but it doesn't hurt to look at it again. Okay, well, the distance formula is just the formula for the distance between 2 points. And it's just based on the Pythagorean theorem, because the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, let's look first down at x2 minus x1, which I'm circling now with the mouse arrow, the bottom of the screen, x2 minus x1. That just indicates the amount of difference there is in the x coordinates. Okay, and if we are looking at this diagonal line here just as a line, well, you know, it sometimes isn't obvious that we can also make it the hypotenuse of a triangle. And that's what this diagram appears to clarify, is that it just shows you that for any diagonal line, you can consider it the hypotenuse of a triangle. And the base of that triangle would be given to you by the difference in x coordinates, whereas the height of that triangle, or this distance that I am now tracing with the mouse arrow, the height of the triangle, is the difference in y coordinates. Okay, so all x2 minus x1 gives you is a length, and all y2 minus 1 gives you is a length. And since the Pythagorean theorem says that hypotenuse squared equals one leg squared plus the other leg squared, or c squared equals a squared plus b squared, this is simply just a way of rewriting and rearranging that. Okay, so the distance formula comes directly from the Pythagorean theorem. And yes, we've seen that before. But again, just be patient because you know, after a couple of sections, we'll get into things that are more challenging. Also notice that it doesn't matter whether you do x2 minus x1 or x1 minus x2. You can do them in any order you want. And you can do x2 minus x1 here, and then for the y's you could do y1 minus y2. It doesn't matter even if you don't keep the order consistent, because when you square something, you change the sign to positive. You force the sign to be positive. So a negative quantity squared is positive, and a positive quantity squared is positive. Therefore, order does not matter with x2s and x1s and the y2s and the y1s. Now let's talk about the midpoint formula. Okay, the midpoint formula. The midpoint formula in a way is really even simpler than the distance formula, because all it's asking you to find is where is that point. Okay, that point that I'm showing now with the mouse arrow, right? The point that's right in the middle of the hypotenuse. That point M is given by the coordinates x2 plus x1 divided by 2, y2 plus y1 divided by 2. All right, and we can see why that is true, because you could think of it as an average. You know, you have an average height, and so y2 is one height and y1 is another height. Well, the average height would be right in between. Okay, and you could talk about the difference between x2 and x1 as a length. Well, if x1 is one length and x2 is another length, well, the average is going to be right in the middle. Okay, so all we're doing is we're looking at the point that is at the average length and the average height, and that corresponds to the exact midpoint of the hypotenuse. A few examples to work on. Find the distance between the points -2, 1, and 3, 4. Alright, so pause the video, do that on your own, then resume when you have an answer. The answer is 5.83, and you simply plug these coordinates into the distance formula and you get the right answer. Find the midpoint between the points -5, -3, and 9, 3. Okay, pause the video, do that, and then resume when you have an answer. Two, 0. Those are the coordinates of the midpoint. 2, 0. And you just use the midpoint formula for that. The points 2, 1, 4, 0, and 5, 7 form a right triangle. Prove it. Alright, now there might be several different methods for this, but what I'd like you to do is pause the video, do this on your own, and then resume when you have an answer or if you get stuck. But you need to prove that those 3 points are the vertices of a right triangle. Just prove that that triangle is a right triangle. So pause the video, do that, and then resume. So here's the basic strategy of the proof, and you probably did do this. You simply plot the points, connect the dots. When you connect the dots, you have a triangle. Then you use the distance formula to show that the square of the longest side, or the hypotenuse, is the sum of the squares of the two shorter sides, or the legs. And of course, most people just think of that or remember it as c squared equals a squared plus b squared, the Pythagorean theorem. And as you remember from geometry, c squared equals a squared plus b squared applies only to right triangles. These are common geometric formulas. Some of these you probably already have in your mind, and some maybe you're a little more rusty on, but you should copy all of these down, especially the circular cylinder, the sphere, and the triangle, just in case you've forgotten those. On the test, you will need to know these formulas, okay? So make sure that you write them down and know them. Here's the classwork, page 10. Please write these numbers down, and we'll see you in class.